Today, I'm gonna talk about the art of messing around. Okay, a few years back, my friend and me were just playing with each other, giving some really hard problems, and yeah. So during that time, while we were just playing, yeah, let me just go with the story, and then we will realize what we realized. So my friend gave me this problem. So the thing was, there's this coordinate plane, right? And there are 2 points, and the 2 points define a line, right? Say the points are 1 1 and 2 1. And now my friends asked me to find a equation of line that passes through these 2 points, right? Now we definitely knew the slope intercept form of line at that point. So we knew that like the equation of this line must be in this form: y is equals to mx plus c for some slope m and for some y-intercept c, right? Yeah. So the line might be something like this. The line passes through both of the points, and it makes some y-intercepts. That means it caught somewhere in the y-axis, right? And it has a slope. Slope means basically the inclination. And we just had to solve for this m and c. Now we didn't really know the formula for the slope and the y-intercept at that point. So what we did was, even though we didn't know the formula, we could just use linear algebra. First of all, just substitute. If you just substitute the points, you get some equations involving m and c, right? And what you get is 1 is equals to, basically substitute 1 comma 1, y is 1, x is 1, so m plus c. Now if you substitute 2 comma, sorry, this was supposed to be 2 comma 2. If you substitute 2 comma 2, what we get was 2 is equals to 2m plus c, right? So x is 2, y is also 2, and you get these equations. Now you can just solve for m and c, considering these as a linear system, right? Simultaneous equations. Now we know that we can convert this to matrix form, right? And then solve using some techniques of linear algebra. So what you can now do is, you can write it in this form. 1, 2, 1, 1 times mc is equals to 1, 2, right? And now mc becomes inverse of 1, 2, 1, 1 times 1, 2, and if this 1, 1, 2, 1 is not linearly dependent, then we can just take the inverse, right? So this becomes 1 by 1 minus 2, and then 1, 1, negative 1, negative 2. That's just the formula for inverse. And you get mc as 1 by negative 1. If you just multiply these things, this will just be 1 minus 2, negative 2 plus 2. So our mc is just negative 1 times negative 1 times 0 by 0. And our mc is just 1, 0, right? Now since we know the m and c, now we know that the y is, our m is 1, our m is 1, c is 0. So y is equals to 1 times x plus 0. So our equation is y is equals to x. So this was easy, right? So yeah, I solved this easily. Even though we didn't know the formula, we just used linear algebra, and yeah, it could be solved easily. Now my friend was getting, like, he was trying to solve that, like, there are some problems that I couldn't solve, right? And what he did was, he gave me this problem, which was insane. So what he did was, he asked me to find the equation of line passing through these 3 points. Let's say 1 comma 1, and somewhere around here 2, 3, 3 comma 2, right? And let's say there's this 4, and if this is 1, 2, 3, 4, somewhere here is 5, so 4 comma 5. Okay, he asked me to find the equation of line passing through these 3 points. And you know that's impossible, right? To find the equation of line, like either we should be just given 2 points, or if there are 3 points, those 3 points need to be collinear, right? And if only if they are collinear, then I can find equation of line. But in this case, clearly these 3 points are not collinear, and my friend is asking me to solve it. So definitely, like I can solve like this piece of line, using different 2 points, but for him that's unfair. Just use all 3 points at once and find equation of line, and that's pretty impossible. And but again, even though that's impossible, I didn't feel like giving up. Maybe what if I just try the previous technique that I did earlier, right? So just mess around, just try whatever you know. So yeah, I thought of doing that. Again, let's assume that we don't even know, like, there if there's a how can there be a line that passes through all 3 points, right? But just assume, right? I mean, even though it's not there, just say there's some imaginary line. Like we don't even know if that exists or not. But say, okay, say there's a line. Say there's a line y is equals to mx plus c, right? That passes through these points, or I don't know, like whatever makes sense. Okay, now we just go with the previous technique that substitute the points. Now if you substitute the points, what we get is 1 is equals to m plus c, 2 is equals to, yeah, again substitute 3 comma 2, y is 2, x is 3, so 3m plus c, and substitute 4 comma 5, 5 is equals to 4m plus c. Again, we can change it to matrix form, right? We can make it into 1 2 5 is equals to 1 1 3 1 4 1 times mc, right? We now let us write in a slightly different form that's easily readable. 133 and c 0.25. Now here we are stuck, right? What we would always want to do is we just want to take inverse of this matrix and take it to other form. But since it's not a square matrix, we cannot take inverse. Again, even if it's not a square matrix, we would be able to solve it if this column matrix over here was in the column space of this matrix, right? But again, that's not the case, because if it was in the column space, basically the third point would have been in the same line, but it's not. So it's not also in the column space. So what we can do now at this point, like what you are desperate is you just wanna have some square matrix that you can take to other side and have inverse, right? Because that's what you did earlier. But that's not a square matrix. So what you want to do now is like just like how you did in like some simple equation, like if you want to solve 2x equals to 5, we just multiply by half and half, and that turns something like nice, right? It's just like this. Let's say if you have 3y to x is equals to 5, and you don't know how to take fractions to other side, right? So what you can do is, if you don't know how to take fractions, just multiply by a number so that they cancel out, so that x is alone and you can solve for x. So you try to do something similar. You just want to make sure that this column vector MC is alone. Now you realize something from linear algebra, that A transpose times A is invertible, right? Is invertible if A is linearly independent. Linearly independent. Now you just realize this fact from linear algebra, and you want to make use of this so that you can solve it. And like just like you read in normal equations, you feel that you don't know, like you just feel. I mean, that might not be the case, but you just feel that, yeah, I can just multiply by anything I want, and then just make sure that MC is alone, right? And then you can solve for it. So you go for that. You don't even know if that's like right or if that's allowed or not, but you just go ahead. Now if you try that, yeah, now you just multiply by A transpose so as to make this invertible matrix. Now if this is our A, now A transpose will just be 1 3 4 1 1 1, right? And you also know that you need to multiply that in both sides, because just like how you did in like normal equations, right? And if you do that, this becomes 1 3 4 1 1 1 1 2 5. And now this becomes a square matrix, and hence it's also invertible because these two columns were earlier linearly independent, right? We take that for given actually. Now this is 4 times 4 is 16, 3 times 3 is 9, 6 and 9 is 25, and 1 is 26. And this is 8, and this is 8, and this is 3 times. And now it seems like it's somehow solvable. Even though you know that there's no such a line, you don't even know how it's being solvable, right? But it is. Like, and just you just go ahead. Yeah. If it's good, then it's good. Now this is 26, 27, right? Yeah. And the next is 8. Now you just want to take inverse and solve for M and C, and you are excited to see like what kind of line is this, right? Once solve for M and C, definitely you can draw a line. You are excited. What kind of line am I getting from this, like from this random messing around calculation, right? So you go ahead. You take the inverse. You are so excited now. You just want to see what's happening, what's going on, how is it being solvable, right? And then you get this MC. Now you just take inverse. We know how to take inverse, right? 1 by determinant is 26 into 3 minus 64. And over here, that this swaps around, this has a negative sign, and 27 8, right? And now your MC will just be 1 by, this is 6 times 3 is 18, 3 times 2 is 6, and 1 7, right? And then 3 minus 8 minus 8, 26. I could actually just multiply right now. Let me do that. So if I multiply, 27 times 3 is 81 minus 64. 8 times 7 is 56. 8 times 2 is 16. With 5 is 21. Is that right? Let me just confirm, guys, with my calculator. 27 times 8, yeah. And then plus 8 times 6 is 48. 8 times 2 is 16. And 208, right. Okay. Now, our MC is, now this is just 14. And this is just 11 minus 4 is 7. And then 7 minus 6 is 1. This is negative 8, right? So you get MC as just 17 over 14, negative 8 over 14, right? And you get M as 17 over 14 and C as negative 8 over 14. Now your equation of line becomes 17 over 14x and then minus 8 over 14, right? Now you are so excited. You want to see what this actually means, right? So let me just copy this and like let's try to plot and see what happens, right? Copy. And like let's get these equations here. Yeah. Now let's see what these equations actually are doing. What do these give us? So now I'll just plot it and let's see what happens. So 17 over 14 by 14 and into that's to 1 minus 8 over 14. So yeah, you see that if you substitute 1, we just get some points 0.6 here around. We get this point 0, 0.6, 0.6. Okay, that's fine. Let's see. It's pretty close. Let's see what's going on. Let's substitute x as 2. Sorry, x as 3 next. Oh, we get 3. If we substitute 3, we get 3.07. We get some points here around. Okay, that's pretty cool. Not really there. Where 0.67 should be here. And the 3 should be here. Okay, that's pretty cool. That's pretty cool. Let's see what's going on. If we substitute now 4, we get 4.28. We get this point around here. So these points aren't too far from the actual points, and also it seems like these points are somewhere in between these points. Like it seems like these new points are trying to average out, or maybe the line of best fit, right? Some points are around here, some are around there. So basically, these points are basically trying to get a line like that's basically makes the best fit for all the points we have. And also in stats, we call that a line of best fit or regression line, right? So yeah, it seems like that's happening. And if you check with multiple points, that's exactly what happens. But we had no idea. We were just trying to mess around, and how come we have this suddenly, right? And now, yeah, now after this, after you see that, now even though this completely looks nonsense, this isn't really nonsense. Somewhere something is going inside this calculation, inside this calculation, somewhere there are some good things happening. We don't know. Like there are actually some like nice things happening inside that we don't know, but yeah, it's going on, and that actually gives us a really like good answer, right? Where how come we just suddenly get this good answer? There must be something going on. And then after you realize that, oh, this calculation is actually helpful, you go on like searching around, and then you learn about like subspaces, projections, and how this multiplying by trans was actually just remove the orthogonal components, and just the projection was there, and then that's what gives us the line of best fit. So you go and start searching around, which is a task for you guys to go and like learn some linear algebra stuff on line of best fit. And yeah, so it turns out sometimes we just like mess around, like you might just discover or find new stuffs, and then that can be pretty helpful. And after you find new stuffs, you can go around and search for reasons why it happened, how it happened, and like what were some underlying stuff that helped. And that's how you make sense of the things happening in maths. So yeah, the moral of the story is like even if you are just messing around, you can sometimes learn new stuff or realize new stuff, or also like you might like understand new things that you weren't understanding till now, and then that's what maths is all about. So yeah, I think you definitely now like found a new way to find line of best fit, right? Just multiply by the A transpose over here, and then it forms a square matrix, and just take the inverse, and that's what gives line of best fit. So that's a new learning. Also, you learned that like messing around is good. And now, like, I wanted to go and like search for the underlying reasons why this method works. And that's what is for today. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming video soon.